In this video, we are going to be going over the concepts of prefixes, equalities, and conversion factors. So the concept of prefixes, understand that this is a special feature of the SI system as well as the metric system. And in essence, these prefixes can be put in front any unit to increase or decrease its size. To give you guys an example of prefixes, as you can see, milli is prefixes that is a prefix that is utilized for making a unit small. Also microgram. Understand that microgram, there's two ways in which it can be illustrated, which is with this U symbol or with the letters MC. I just highlight the abbreviations in yellow. When it comes to equalities, understand that these are going to be utilized to describe the same measurement amount of two different units. And they are written specifically to give relationship between things that are in the metric system, things that are just in the US units, and even relationships between the metric system and the US unit. So as you can see here in the bottom part of the right side of the slide, for example, the relationship between 1 meter and 1,000 millimeters, that's an example of a metric unit related to another. The relationship between pound and 16 ounces, that's an example of US units related to one another. And if we have the relationship that is 2.20 pounds equals 1 kilogram, that's a relationship between US unit and a metric unit. As you can see in this slide, the prefixes are summarized in table 2.4, and they are going to be very useful when it comes to conversions, which is something that we're going to be doing in the following slides. Now, even though there are many prefixes, the only ones that you guys are responsible for are the ones that are present in table 2.4. As you can see here, I'm going to zoom in into the table so you guys see them more closely. We have prefixes that increase a unit. Examples of that include tera, which has the symbol of a capital T, giga, which has a symbol of a capital G, mega, which has the symbol of capital M, and kilo, which has the symbol of a small case K. Now, the important thing to remember here, I'm just going to highlight the items that are important for you guys to know. What is the prefix? What is the symbol? And the scientific notation. The reason why I don't say to memorize the numerical value, because if you messed up and you forget a 0, as you can see, it can actually hinder you when you're doing problems, and you can get the problem wrong. But if you remember the one in the scientific notation, as long as you know how to enter it into your calculator, you're good. Now, prefixes that decrease the size of a unit include deci, centi, milli, micro, nano, and pico. As you can see in the second column of table 2.4, you have the symbol for them. You have the numerical value, but similarly, just remember the scientific notation for them. Why is it important to know these prefixes? Well, the relationship of a prefix to a unit can be expressed by simply replacing the prefix with its numerical value. So let's look at a relationship as an example, which now I'm just going to utilize my pencil. I'm just going to box it. Here we have the relationship between kilometers to meters. So 1 kilometers, okay, if we replace the kilo word with its numerical value, that is going to give us the relationship between kilometers and meters. Understand that meters is the basic unit compared to the kilo prefix. Now, as we move right along, we need to be familiar with writing conversion factors. And even though you may not think about them, conversion factors are everywhere. If you look at any food product that you have at home, it could be liquid, it could be solid, you will see that conversions factors are present. To give you guys an example, if we look at a box of cereal, and as you can see, these are Cheerios. This is a larger one. So this specific box of cereals contains 2 1 pound 4.3 ounces bags. This 1 pound 4.35 ounces is the same thing as saying 20.35 ounces, or in other words, 576 grams. As you can see, the conversions for all these units in between metric and US are present in the label. Now, in table 2.7, you guys have some common equalities. Understand that these equalities will not be provided to you in the exam, but it is important that you have this table handy when you're solving homework problems and even exam problems, okay? So, this table summarizes some of the relationships between metric to metric, some of the relationships between US and US, and lastly, the metric US relationships. Understand that if there is a relationship that you guys are required for a problem, but is not included in table 2.7, specifically for the US or the metric US, then I provide those. For the metric to metric, I'm going to show you guys the number line method. And that's how you're going to be solving those conversion factor problems. We're going to be practicing in a few moments. Or we're going to be practicing in a few moments. So, now we are going to dive into solving problems that have to do with conversion factors. Now, this is one of the main things that you get in this class. It is very important to know how to solve this, not because we require it in the class, because it is really useful. If you decide to travel anywhere in North America, for example, you decide to go to Canada, or even if you decide to go to Mexico, they do not use the US system. They actually use the metric system. So it is important to know if we're going shopping, or if we're going to a restaurant, or even to a grocery store, that we understand what we're really buying and the price that we are paying for items. So these are the guides to problem solving using conversion factors. So as you can see, in the process of problem solving in chemistry, it requires at times one or more conversion factors in order to change from a given unit to a needed unit, okay? So the 3 things that you need to identify when you're trying to solve these problems are: number 1, understand what is the given unit. Number 2, understand what is the needed unit, and all of that is going to be stated in the question. Lastly, you need to find what is the conversion factor that is going to be connecting my given unit and the needed unit. Now we're going to proceed to look at examples in order for us to practice on how to solve these. So here we have 2 examples, okay? Now, in example number 1, as you can see, the problem states a doctor makes an incision 2.5 centimeters long. What is the length of the incision in meters? So I need to write down what is given, which is 2.5 centimeters. What do I need to change to? In other words, what I need to find, so the unit that I need to find in this case is going to be meters, okay? Now, looking at these units, I can already tell that this problem is going to be a metric to metric conversion. So when I have a metric to metric conversion, then I'm going to be utilizing the number line method. And then the number line method is that basically now we have the prefixes that are illustrated in table 2.4 in a number line form. Because one of the beauties about the metric system is that they are related by tens. So if we put them in a number line, all we have to do at the end of the day is move the decimal place to understand these conversions, okay? So you guys understand what this number line thing, in the top of it, we have the name of the prefix. As you can see, tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. Okay? In the bottom, we have the symbol for those prefixes. Letter capital T for tera, capital G for giga, capital M for mega, small case K for kilo, small case D for deci, small case C for centi, small case M for milli, small the micro unit, or remember micro can be MC, the small letter N for nano, and the small case P for pico. Okay, that's what we have there. As I mentioned, okay, when we are doing this, all you have to do is this number line tells you how many places we're going to move to the right or to the left, these decimal places, in order to do this conversion. Now, if we look at the problem that we have in hand on number 1, you see, oh, okay, what is given to me is going to be specifically centi. So I mark where centi is in my number line. Now, if I look around, then you have to ask yourself, wait, there is not meters in it. Well, because meters is going to be part of the basic unit. That's where we have our meters, liters, second, grams, so on and so forth. So our basic unit, okay, the one that does not have a prefix, that's where it lives. So as you can see here, if I'm going from centi to the basic unit, I'm going to move that decimal place 1, 2 times. From right to left. So in order to do this conversion, my final answer is going to be where I take my 2.5 and then I do 1, 2. Now the decimal place is going to live here. See that we have a pocket? That pocket will be filled with a 0. So my final answer for this conversion is going to be 0.025 meters, or you can say 0.025 meters. Remember, when we're doing metric to metric, please utilize the number line method to solve those problems. What if we have a different type of relationship? So let's read the next problem. What is the weight in pounds of an animal that weighs 150 kilograms? So when we have this, again, let's write what is given. What is given to us is 150 kilograms. What we need to find is, how is that related to pounds? Okay, so when it comes to this, then you have to go to table 2.7. And why do I direct you there? Because this is going to be a relationship between metric and US unit. Okay, so we can find the conversion factor in table 2.7, which means that 1 kilogram equals 2.20 pounds. And then for this, instead of doing cross multiplication, what I'm going to ask of you is to actually do dimensional analysis. What is dimensional analysis? We are going to be writing the number given, which is 150 kilograms. And in dimensional analysis, we're going to take this equality, and in the bottom of that fraction, we're going to put the unit that matches what is given. That looking at this equation or at this equality, we're going to put 1 kilogram. On the top of it, we're going to put what that kilogram equals to, which in this case is going to be 2.20 pounds. So when we actually do this, what happens is that the kilograms are going to cancel the kilograms, and that means that our final unit present in this problem is going to be pounds. So in this case, when I take these two numbers and I multiply them, because all I'm doing is multiplying now across. When I take 150 and I multiply by 2.20 and I divide it by 1, then I see that my value is 330. Okay? Now, let's verify if our final answers have the correct number of sig figs, because in all of these problems, when we do them, we have to verify, hey, did I write my final answer with the correct number of sig figs? Let's just verify that really quick before we move on to the next problems. So in the first problem, we're giving a value that is 2 sig figs, and our final result also has 2 sig figs. So we're good there. So remember that the reason why we're doing sig figs here is because here we're doing multiplication and division. When we look at the second problem, the value given has 2 sig figs, and the result that we wrote as a final answer also has 2 sig figs. So understand that in here we have the correct answers with the correct number of sig figs. So to practice further, as you can see here, I'm specifically going to do in this video number 1 and number 4. Okay, so as you can see, the instructions on this example from the worksheet says complete each of the following conversions to the proper number of significant figures. Okay, and we're going to clearly show the setup in order to show the answer. Okay, so remember, when we are doing these problems, we need to make sure that the number of sig figs given are also shown in the final answer. So when it comes to this, let's just keep that in mind. So on number 1, I have 2 sig figs. So I have to keep in mind that I need to report 2 sig figs in the product or in the result. On number 4, I'm giving 3 sig figs. So that means that my final answer needs to have 3 sig figs. So I'm just making those mental notes already. So let's move on to actually solve the problems. In the first one, as you can see, we're going to be changing from meters to millimeters. What does that mean? That we're doing a metric to metric conversion. When I do a metric to metric conversion, then I'm going to use the number line method. Okay, so to go over the number line method again, I'm going from meters, which is where I start. So I'm giving meters. Remember, meter is a basic unit, so we're standing right here in the basic unit. Then the relationship between meters and millimeters, as you can see, milli is going to be here. So I'm going to move my decimal place 1 time, 2 times, 3 times from left to right. So my value of 0.30, I'm going to move that decimal place 1, 2, 3 times. And now the decimal place is going to be there. I don't need to write it that for my final answer because remember that I need to express it as 2 sig figs. So when I do this, again, I created that well. I'm going to fill it with a 0. So that means that at first I'm going to say, okay, in 0.30 meters, there are 300 millimeters. Now, my final answer needs to be in 2 sig figs. So in this case, because 300 only has 1 sig fig, I'm not going to write 300. I cannot write 300 decimal place because that makes it 3 sig figs. So I need to convert this number into scientific notation. So my final answer for this problem is going to be 3.0 times 10 to the 2 millimeters. Let's proceed to number 4. In number 4, I have given a metric unit and I need to convert to a US unit. So I go to my table 2.7. There you will find that 1 inch equals 2.54 centimeters. So in this problem, I'm going to do dimensional analysis. I write 10.0 centimeters, multiply, and in the fraction, I'm going to put my equality. How am I going to put the equality? In the bottom, I'm going to put what matches what is given, which is 2.54 centimeters. On top, I'm going to put what it equals to, which is 1 inch. So in this case, that means that the centimeters cancel each other. And then when I take that 10.0 times 1 and divide the whole thing by 2.54, understand that based on that value, I need to round the final answer to 3 sig figs. So the final answer for number 4 is going to be 3.94 inches. So 10.0 centimeters equals 3.94 inches.